Algebra, Unit 8, Lesson 1, Notes 1, Factor by GCF. You have used the distributive property to multiply a monomial by a polynomial. You can work backwards to express a polynomial as the product of a monomial factor and a polynomial factor. This is referred to as factoring by GCF, or greatest common factor. Factoring a polynomial involves finding the completely factored form. And I'm going to highlight that. That's going to come into play a lot more later. Completely factored form. Factors are the quantities being multiplied together to form an algebraic expression. So we've worked with the distributive property. Factoring is the opposite. It's the inverse. If we take a look using our distributive property, multiply the following expression using the distributive property. So we're going to multiply 4x squared by 3x to the fifth. 4 times 3 is 12. And remember, our shortcut with multiplying variables with exponents is you keep the base and add the exponents, so it becomes x to the 7th. And then we're going to do 4x squared times 5 as well. 4 times 5 is a positive 20. And there's no x term with the 5, so we just carry down the x squared. So that's what we have already learned. Oops. Using that answer of 12x to the 7th plus 20x squared, let's talk about factoring. Now we know what the answer is going to be because we just moved forward from it, but now we're going to go backwards and pretend we don't know what the answer is. So we need to find the greatest common factor. The first thing I'm going to look at is 12 and 20. So if we were to do this 12, our factors are, well, we have 1 times 12, 2 times 6, and 3 times 4. Let me squeeze those in there. Okay, those are our factors of 12. Our factors of 20, we have 1 and 20, 2 and 10, 3 doesn't go into it, and 4 times 5 does. So the largest factor that is in common is a 4. So we can pull out a 4. Now when we look at our variables, x to the 7th and x squared, we want to know how many x's we can pull out from both of them. Really, the shortcut way to think about this is you want to pull out the smaller variable with the exponent, the smaller exponent. Okay, so we're going to pull out an x squared. Okay, and when we do that, we'll have more practice of this later. 12 divided by, let me get my arrow, 12 divided by 4 is 3. X to the 7th divided by x squared. We're going to keep the base and subtract the exponents. X to the 5th. Positive 20 divided by 4 is positive 5. And x squared divided by x squared is 1, which means there's no x term here. If we didn't have this 5 here, we would have to put a 1. But because we have the 5, we don't have to put anything more. And if you look, it matches the original problem over here. So let's practice just finding the GCF. Letter A, find the GCF of the following. Work on your numbers first, 24 and 18. While they're both even, I know 2 goes into them, but there is something higher. 3 times 8 is 24, but 3 doesn't go into 18. 4 goes into 24, but not 18. 5 doesn't go into either. 6 goes into 24, and 6 goes into 18, so that's a contender. 7 doesn't go in. 8 goes into 24, but not 18. It looks like 6 is our largest factor. So we're going to pull out a 6. With your variables, pull the smaller exponent one out. So we'll pull out x to the 3rd. And that is the GCF. Letter B, 30x minus 50x to the third. The GCF between 30 and 50, I know 10 goes into them, and 30 divided by 10 is 3, 50 divided by 10 is 5. That is definitely the largest factor we can pull out. With your variables, pull out the smaller one. So our GCF is 10x. I want you to do letter C. So to factor by GCF, we first have to find the GCF of the coefficients. And then we have to find the GCF of the variables, which means always pick the smaller one. And then we factor each term, divide each term in the polynomial by the GCF. Express the polynomial as the product of two factors. Letter D is just variables, so we don't have to look at the coefficients because the coefficients are 1. It looks like they both have an x in common, and that's it. So we pull out an x. When we pull out an x, what we're really doing is dividing by x. Well, when we divide by x in the first term, the x's go away, and I'm left with y. When we divide by x's here, the x's go away, and I'm left with z. And we just need to bring down that minus sign. If we wanted to check it, we could distribute. X times y is xy, minus x times z is xz. So we do, in fact, get our original problem, so I know that I factored correctly. Letter E, 40 and 16. Now, you could actually use your calculator to find the greatest common factor. Sometimes it's a lot easier just to do it in our head. Some of them are fairly easy. Sometimes they won't be as easy. So if you take a look at your calculator, I want you to hit the math button. And then on the top it says math, num, complex, probability, fraction. They're abbreviated, of course. I want you to arrow over to NUM for number. Okay, so we're going to, I'll write this up here. The math button. Then we're going to arrow over to num. And then mine is number 9. Yours might be different, but you're going to select GCD parenthesis. Okay, that stands for greatest common denominator, which really is the same thing as greatest common factor. And then you hit enter, and on your calculator you should see GCD parenthesis. Well, I want to know the greatest common factor of 40 and 16. So I type in 40, comma, the comma button is above the 7, 16, and then close your parenthesis and hit enter. So it tells me that my greatest common factor is 8. This only works for the coefficients, okay? The variables, it's not too hard to do variables. You just pick the smaller one. So I have 8x to the 4th. And again, remember we're dividing. 40 divided by 8 is 5. X to the 4th divided by x to the 4th cancels to be 1. So we don't need to write the 1 because the 5 is already there. Plus 16 divided by 8 is 2. X to the 6th divided by x to the 4th. We keep the base, subtract the exponents, and we get 2x squared. Okay, let's do one more on this page. Let's do H. 42 and 7. Again, you can use your calculator if you need to, but this one's pretty simple for me to see since 7 is a prime number. I know that 7 is my GCF because it goes into 42 as well. And then look at your variables. You have two different sets. Look at them separately. If I look at just my A's, A squared is the smallest. And if I look at B's, B to the 3rd is the smallest. Okay. So we start back in the beginning. 42 divide by 7 is 6. A to the 3rd divided by a to the second. We subtract the exponents. I'm left with a single a. And b to the fourth divided by b to the third. I'm left with a single b. Oops, did not mean to do that. Okay, so now let's look at our second part. Positive 7 divided by 7 is 1. Okay, so that cancels. I'm not going to write it just yet. A squared divided by a squared is also 1. B cubed divided by b cubed is also 1. So what we are doing is we're technically dividing this whole thing by itself. I can't leave this spot blank, and here's where it comes into play. We have to put a 1 there. Because it doesn't just go away. It's not plus 0. It's plus 1. There is something there that 1 is holding that place. So there we have our answer. Okay. Let's flip to the back. I'll do a couple more with you. Let's look at one with 3 terms. Now, I know I taught you that little calculator trick, but unfortunately that only works with 2 numbers. There is a way around it. So the way you can do it, on your calculator, you would still hit the math key. You would arrow over to number, and you would still pick GCD parenthesis. So the trick is you can only do 2 numbers. So you do the first 2 numbers. So we'll do in this one GCD of 48, 24. When you do those 2, you would get a greatest common factor. Let's see, 48 and 24. I'm just doing it in my calculator. You would get a greatest common factor of 24. Okay? The trick is go through that process again. Hit math, number, arrow over to number, GCD parenthesis. But this time, you're going to use this number, which happens to be 24, and then your third number of 36. So when you do that, the greatest common factor of 24 and 36, you would get 12. Which means for all 3 numbers, my greatest common factor is 12. You don't have to do it on your calculator. Okay, you can list out the factors if that's easier. Or you can, a lot of us can do it in our heads. That's fine too. Just make sure you're pulling out the largest number you can. Okay. Variables, again, are done the same. Just pull the smallest one, which happens to be d to the third. Okay. 48 divided by 12 is 4. D to the 6th divided by d to the third. You keep the d, subtract the exponents. 24 divided by 12 is a positive 2. D to the 4th divided by d to the third is a single d. 36 divided by 12 is a positive 3. And d to the third divided by d to the third cancels to be 1. So I don't need to write it. And I don't need to write the 1 again because there's a 3 there. I don't need a 1 as a placeholder. Okay? All right. Let's do another one, maybe a little more complicated. Let's look at letter U. I think letter U printed a little weird on your page here, but that's okay. Okay. 12, 20, and 8. You can use the calculator trick, but these numbers are fairly small. I always start with the lowest number, which is 8. Can 8 go into 12 and 20? It actually can't go into either. So what's my next factor? So here's what I mean. You have 8. My factors of 8 are 1 and 8. And 2 times 4. Okay, so start at the top. Can 8 go in? No. Can 4 go into all those numbers? Yes. So 4 is going to be the GCF. A little bit quicker than using the calculator. The smallest variables, if I look at the x's, I have a single x. If I look at the y's, I have y squared. Okay. All right. 12 divided by 4 is 3. X to the second divided by x is x. Y squared divided by y squared cancels out. Negative 20 divided by 4 is negative 5. X squared divided by x is x. Y to the fifth divided by y squared is y to the third. Positive 8 divided by 4 is positive 2. X divided by x cancels out, so I don't write an x. Y to the fourth divided by y squared is y squared. Okay. And let's do a word problem. Let's look at W together. The area of a rectangular garden is represented by the expression 8w squared minus 2w. Determine the dimensions of a garden. Remember, we have a rectangle. If we're talking about area, remember area is length times width, or base times height. Okay, so they're giving us the area of 8w squared minus 2w. This is the area. We need to find the dimensions. Well, we can actually factor to find our two dimensions, because when we factor, we get a product of two factors. So 8w squared minus 2w. My GCF between 8 and 2 is 2. And my smaller variable is w. So 8 divided by 2 is 4. W squared divided by w is w. Negative 2 divided by 2 gives me negative 1. So let's hold off on writing it. W divided by w also gives me 1. So now I know I have to, in fact, write that 1 as a placeholder. So my dimensions are 2w and 4w minus 1. So, for example, it could be something like this. Okay, I want you to finish the rest of the problems on the front and back.